Hi, third graders. Today, I've got my sleeves rolled up, got my apron on, because we are going to be mixing it up. What? You see, when you're in third grade, you begin to learn what does and does not dissolve in water. Why is that important? Because the clothes that you're wearing were made using water, and that food that you like for someone to cook for you, well, that can involve water too. So it's really important for you to understand what does and does not dissolve in water. Now, to do that, we're going to be using some things you might find around your house. Does that mean you can just start pulling things out of the cabinets and start mixing them up? No, because when you're using and making science experiments, you want to be safe. So, if you're going to try any of these experiments at home, you have to have a grown-up with you. Now, your grown-up is not your 10 or 12-year-old brother or sister. Your grown-up has to be a grown-up, okay? So now that we have those rules out of the way, let's talk. When you're in third grade, you've already been learning about matter, solids and liquids and gases. You've been doing that since you were in kindergarten. And most of our experiments today are going to involve water as a liquid. But our first experiment is going to involve two solids that I know you are quite familiar with. One, salt, and the other is pepper. Now, I'm going to take the salt. I'm going to pour a little into this solid cup. Now, I'm going to take some pepper, pour it into the cup. Now, I'm going to start mixing these two things together. Exciting, isn't it? Now, when I'm doing this, well, I can still look into the cup and see the white of the salt and the black of the pepper. And that's cool. It's mixed up. But, now, this is just as if you and I were going to trade places. If I went to your house and you came here to our offices, you're still you, I'm still me. We just traded places, right? So, in this case, it's just mixed up. But, what if I ask you to do this? What if I said, hey, how can you separate the salt from the pepper without getting it wet and without touching it? Can you come up with what you could do? Let's think about it. Let's take a piece of paper. And if you're thinking that I could probably separate the salt and the pepper, well, it's still mixed up. Now I can take my finger and go, there's a speck of pepper and there's a, okay, that's going to take a long time. But what if I use one of these? What if I had a balloon? Now, what does a balloon need to get bigger? Air, right. Okay, and just rub it against my sleeve, and when I do that, what's happening? Can you hear that? There's my pepper. What? Okay, how did this happen? If you're thinking static electricity, well, you're right. You see, when you rub a balloon against your shirt or against a carpet, you're building up static electricity. Have you ever seen lightning? Lightning is a form of static electricity. If lightning strikes you, oh yeah, that's not good. But the balloon, kind of fun. Now the pepper doesn't weigh as much as the salt, so the pepper loves to take a ride on my beautiful balloon. That's really cool, isn't it? Okay, so what if we wanted to mix a solid and a liquid together? Now, let's get our cup. And if I were in your classroom, I would shake this up, this mystery solid, and I would ask you to guess what it is by wafting it. You simply wave your hand over the top of the jar and you would take a sniff to see if you could guess what it is. But I'm not Willy Wonka, and this isn't smell-o-vision. So, see if you can guess. I'm going to put some of the solid into the cup, and then I'm going to add liquid water. Yeah, you know what it is now, don't you? Let's stir it up. This is Kool-Aid. Now, when I'm stirring up the solid Kool-Aid into the water, it begins to break down in the water. It begins to dissolve in the water. How many colors do you see? You see one. So we have created a wonderful solution. Now, so the Kool-Aid dissolves in water. That's totally awesome because that's nice. Now, what if I asked you that question? How can I separate the solid Kool-Aid from the water? What's that? You think using the balloon could help? That's a great thought. So I'll create some static and nothing. But it's a good thought. Now, what if there were a window in this room? If there were, I could put the Kool-Aid into the window. And the sun's energy would do what? Dry up the water. I hear that a lot, but there's a science word that we can use. You see, this liquid is going to have to turn into a gas, and that word is evaporation. So the water would have to evaporate. Now that could take a week. It may take a couple of weeks, depending on how much water is in the cup. But at the end of that time, the water will evaporate, and the only thing we're going to be left with are going to be our solid Kool-Aid crystals. If you want to try that at home and you don't have Kool-Aid, you put salt water into a jar or a cup. Just take a little salt, add some water, stir it up, put it in a window, mark the top of where the water is with a little pen or with a marker so that you can watch how quickly it evaporates and make a prediction, a smart science guess about when you think that's going to happen. Now, let me ask you a question. What color is water? Well, if you're thinking water is blue, water is actually clear. So, let's get another cup. Let's add some water. And this time, let's put in a liquid known as food coloring. Now this happens to be blue, so when I add it to the water is going to turn blue, right? Now, stir. Exactly. So you have blue water because the food coloring dissolved in the water. That's important because you're going to use food coloring to make all those great colors you see on cakes and cookies, right? Now, suppose I get out another cup, and this time, instead of using water that's room temperature, I'm going to use water I've heated on the stove. Water boils at 212 degrees Fahrenheit. Now, when water is heated, that means the water has more energy. It means the molecules that make up water are going to be moving faster. How can we learn that? Well, that took a while to turn blue, right? But if I add the food coloring to the hot water, yeah, chances are I won't even have to use a spoon to stir this up because the molecules are moving faster because the water has heat, and that means it has more energy. So, there you go. Now, suppose I want you to take a look at this. Now, if I were in your classrooms, a lot of you would tell me that looks like soda. Soda. In fact, what's in this bottle is the same thing that's in this bottle. It's a rock, Charlie Brown, it's a rock. Now, watch as I begin to move this rock, and you can see the dirt that comes off the rock, right? So, there's a rock in this bottle, and that's the dirt from that rock. Did the dirt dissolve in the water? Yes, indeed. But not so fast. There's something else in the bottle. If you look at the bottom of the bottle, That stuff's not dissolving. And that stuff is sand. Sand doesn't dissolve in water. So the dirt dissolved, and I'm telling you, if you've never gone outside after it rains and made like mud pies, you know, where you pretend you're cooking and you make your out of mud, I always thought it was fun. But if you look at the bottom, you're going to see the sand. Sand doesn't dissolve. Now, do you remember when we were talking about the blue water? What if I had blue water and I added something that's kind of yellow or kind of a greenish color? So what's happening here? You can see that the yellow greeny stuff is floating on the water, right? And it's a liquid because it's taking on the shape of its container. You can also, well, if I turn it upside down, where does that greeny yellowy stuff go? Still floating. But what if I hold it to the side? Still floats, right? But what if I shake it up? There you go. A perfectly wonderful, just solid blue color. I mean, it's actually sparkling. I didn't put any glitter in there. What's happening? Whatever that yellowy, greeny stuff is, it's beginning to separate from the water. So here's my water that's blue that I colored with food coloring, but here is the yellow-greeny stuff again, separating from the water. So that yellow-green stuff must be oil. Exactly. It's just cooking oil. You ever had a salad, someone gives you a bottle of salad dressing? Did you ever read the back of the salad dressing where it says shake well before serving? You know why you have to do that? Because the oil in the salad dressing will float to the top. So you have to shake it before you can serve it. So oil and water, the oil is not going to dissolve in the water. Now, I want to tell you about my grandmother. She was a wonderful, wonderful lady who loved to sew, she loved to cook, and she loved helping other people. But one thing that she did that always kind of confused me is that she used to make her own toothpaste. Yeah, that's right. She'd take a cup and she'd use baking soda. And she put a little bit of the baking soda into the cup. And then she would add just a wee bit of water, just a wee bit. Oh, I may have put in too much, but that's okay. We're going to stir. Ah, it was just the right amount. Because when you start to stir, remember the baking soda was a solid, and then we added water. Why, I have toothpaste. Now, I know that sounds strange to you. She also used to go outside and she'd find a little bit of a mint. A mint is a plant that grows, and she would crush it between her hands, and then she'd put it into the toothpaste and gave it a little bit of flavor. So she'd make her own toothpaste. Okay, I know, that sounds strange, but here's something even stranger. I had another wonderful neighbor named Miss Dove, and I loved going to Miss Dove's house. But Miss Dove not only made her own toothpaste, she made her own toothbrush. Guess what she made her toothbrush out of? No, it wasn't metal. No, it wasn't plastic. She used a stick. That's right. She would go outside, find a twig, and I could still see her sitting in her rocking chair, taking the end of her thumb and making the end of that stick really nice and soft. She would put the stick into the toothpaste and then brush her teeth with the stick. Are you grossing out over that? Yeah, because when I was little, I would think, ooh, I don't understand that. And I didn't want to ask questions, so I'd wait till we leave and I'd ask my mom, what's up with Miss Dove and the stick? And my mother explained that when Miss Dove was growing up, her family didn't have a lot of money. And you had to make do with what you had. And what she had was a stick. And do you know what else Miss Dove had? Probably the prettiest smile that I've ever seen. Oh, she was a wonderful, wonderful lady. But Miss Dove and my grandmother, just for kicks and giggles, would do this experiment for me. They were grown-ups. Yeah, right? Now, what just happened here? I had baking soda that dissolved in water, right? And then I had this is not water. It's clear like water, but this is actually something called vinegar. And what we created here was a chemical reaction. Watch this one. Let's take your Kool-Aid, because I know when I'm in 3rd grade, sometimes some of you talk about making volcanoes with a grown-up. So if I have your Kool-Aid and I add in a solid baking soda, what just changed? Did anything change? Color changed a little bit, didn't it? So now, if I add some vinegar, are we going to have a chemical reaction? Yes, we are. Some of you say that reminds you of lava from a volcano. Now, what's actually happening here in this chemical reaction is that there are little tiny bubbles through there. In fact, some of you say that when you look at this, it reminds you of soda. But those little bubbles are gas, right? Have you ever had anyone take a soda can and then they shake it up and then they open it and psh, right? Well, that's because of those little bubbles that have been created. Now, if you were to smell that though, you know that doesn't smell like soda. That smells like vinegar. Now, I know you're really smart, but there's something that I like to do at this point, and I know it's a little kindergartenish, but I think it's a good lesson to remind you about. Let's take 2 cups, and let's say you're going to throw your best friend a birthday party. So you've got things set up for the cake and the icing. You're going to make cookies, and you're going to make a punch. And you believe that your best friend's favorite color is blue until they call you on the phone and say, my favorite color is purple, and they want a purple cake. Purple cake, how you gonna make purple cake? You've got like less than an hour. So what are you going to add to the blue? Exactly, you're going to add red. So this is a simple mixing it up experiment. So you've got blue, you put in the red. Are you going to get 2 colors, 3 colors? Just 1 color. And that color is purple. Da-da-da-dum-bum-bum-bum-ba-da-da. Now, let's say you think, okay, you're going to make purple cookies. So you get ready, you put in your blue, but the phone rings and your friend says, oh, I want the color of cookies you see on St. Patrick's Day. What color do you see a lot on St. Patrick's Day? Indeed, green. What do we add? Yellow. So by adding the yellow, oh, would you look at that? You get green. Now, suppose, well, my favorite color is yellow. And if I made yellow punch, I don't know if anybody would want to drink yellow punch. Think about it. So let's make it orange. And to make this orange, I have to add, yes, you're brilliant, I have to add red. Okay, so that's awesome. Now, remember when we're talking about solutions and everything being that one color, because we know things have dissolved. What if I start adding these colors together? What color do you think I'm going to get? Make your science predictions, your smart guesses. And actually, if they were equal amounts, I'd get more of a black color. Now, if I add vinegar to that, well, nothing happened. I forgot something. Could you please tell me what I forgot? Baking soda. You are exactly right. So I will add, I'll add the baking soda and we get a chemical reaction. That's great. Now, let's set that one aside. Okay, I am making a mess and I am a grown-up. Let me clean this up very quickly. Now, let's take the green and the orange, mix it together. Let's add in a little more water, right? Now, suppose in this one, I want to add a liquid. We're going to add liquid soap. I'm just going to pour that in. It's kind of cool looking too, isn't it? Now, I'm going to stir that up. Now, suppose I added some baking soda. Change colors again, right? Now, if I add the vinegar now, do you think I'm going to get a reaction? I mean, we put soap in this. What do you think? Let's see. Yes, but this time it's more of a foam, like the soap would have. Now, this is really cool, and I hope you can see it, but let's add a little blue food coloring. Do you see how the blue food coloring is kind of being very still on the top? It was dissolving a lot before, wasn't it? So if we put in a little yellow dot, and we put in a red dot, I always think that reminds me a little bit of a snowman. Now, we haven't added vinegar. You're exactly right. So I'm going to mix these colors up, because when I mix my three colors, I get a bit of a rainbow. What? Taking those three colors, you can make any color. So let's add the vinegar. That's pretty cool. That's pretty cool, and it's spreading on the table. Isn't that great? So, what have we learned? We've learned that things like KoolAid dissolve in water, and that's a good thing. We also learned that things like oil don't dissolve in water. And we've learned that when heat is added to water, things dissolve more quickly, don't they? Which means that after this video, I think I'm going to get myself a cup of tea. Do you think my tea in my tea bag and my sugar are going to dissolve quickly in that hot water? You betcha. Hey, you have been wonderful listeners. In fact, you've been waterful, absolutely waterful. And I've made quite a mess. Clean up on aisle 2. Clean up on aisle 2. I have to clean up now. You have a great day. Thanks for watching.